Hey guys, so I made this video to review a few of the questions that I noticed either half or a majority of you guys got wrong for the Unit 3 progress check, the multiple choice questions. Alrighty, so here's the first question. If g of x equals ln of x and f is a differentiable function of x, which of the following is equivalent to the derivative of f of g of x with respect to x? Alrighty, so basically they're asking us to find the derivative, d dx, of f of g of x. Okay, now here if you notice, this is composition of functions, right? F of g of x. So what we want to do here is, or what we need to use rather, is chain rule. We know we take the derivative of the outer function, so that's f prime of, keep the inside the same, times derivative of the inside, right? That's g prime of x. So that's literally chain rule definition. And now we plug in what we know. So they told us g of x is ln of x. So that means we have f prime of ln of x times, if g is ln of x, then g prime would be the derivative of ln of x. And I'm going to write a little bit more here to get kind of slow. Now the derivative of ln of x is 1 over x, right? So we have f prime of ln of x. And here I'm going to write it, or I'll write it like this, times 1 over x, which, if you notice, is that guy right there. Right, so f prime of ln of x over x. That's the answer. Cool. Cool beans. Alright, so here we go. Let's go to the next one. Number 2. Okay, so here we are. This is number 2. For which of the following functions is the chain rule an appropriate method to find the derivative with respect to x? So basically the question is, for which of these following functions do we need to use chain rule? Is chain rule appropriate? Chain rule, remember, we use that for composition of functions. So basically we're looking for functions that on the inside they don't have just that lonely x, right? So if we look at number 1, this one is in the form of sine of u, where u is that 3x squared. So that's definitely composition of functions, definitely need to use chain rule to take the derivative there. Let's look at the second one. There we have e to the x, so that's a function on its own, right? And we have that, just that lonely x in the power. So no composition of functions there, no chain rule yet. And then times, product, times tangent of x. Okay, also just a lonely x on the inside, no composition of functions, so we do not need chain rule. And then the last one is tricky, right? It looks like a quotient rule because we see a fraction, we see division. However, if you notice in the numerator, there's no x's, no variables in the numerator. So we could rewrite this as 8x4 minus 2x to the power of -1, right? And that means this is in the form of u to the -1. Okay, so definitely composition of functions. We can use chain rule to take the derivative there. And that leaves us with 1 and 3, so our final answer is D. Okay? All right, let's go on to the next one. Question number 6. So they gave us a table of values there. Notice we have f of -2, f prime of -2, g of 4, g prime of 4. All right, so it seems like we're going to do a question about inverses maybe. We'll see. The point -2, 4 lies on the curve in the xy plane given by the equation f of x g of y equals 17 minus x minus y, where f is a differentiable function of x and g is a differentiable function of y. Okay, so f in terms of x and g in terms of y, g of y, got it. Selective values of f, f prime, g, and g prime are given in the table above. What is the value of dy dx at this point? Okay, so they're asking us for dy dx, that means derivative, and at some point we need to plug in -2 basically, right? That's your x comma y. So we have this equation, f of x, g of y equals 17 minus x minus y, and the question is asking us for dy dx, right? Meaning we have to take the derivative of this equation and see what we get, but we have to do it carefully. Notice that it's an implicit equation, meaning the x's and y's are mixed up together, right? So all the x's are not on one side, all the y's are not on the other side, etc. So anyways, here we go. to take the derivative of the left side, we notice that there's a product there, right? So f of x, the derivative would be f of x times g prime of y. But since we're taking a derivative in terms of y, don't forget dy dx. Plus, still product rule, so plus g of y times f prime of x. Right, that's the left-hand side, and then the right-hand side, derivative of 17 is 0. Negative x, we get negative 1, and then of negative y, we get negative 1 dy dx. From here, we need to solve for dy dx, so get them on the same side. Okay, let me show you how I do this in my head. So in my head, I know that I'm going to move these two to the left, and everything else goes to the right. So we have dy dx, f of x times g prime of y plus 1. So what I did here is that I already factored it out. The dy dx is going to be the common factor. And this guy, to get it to the other side, I know I had to add it, right? So that's where the plus 1 came from. That plus 1 right there. Okay, so equals, I'm going to move these to the other side, and there's a negative 1 there already, so negative 1 minus g of y times f prime of x. Cool. And then we divide, so dy dx equals negative 1 minus g of y times f prime of x over f of x times g prime of y plus 1. Okay, dokes. I need space, so let me make some space. This is our equation, and now it's a matter of plugging in the point negative 2 comma 4. So we have dy dx negative 2 4. I believe this is correct notation to signify that we're plugging in, or signify? I don't know if that's a word. That we're plugging in negative 2 4 into the derivatives. So it'd be negative 1. Oops. We'd have negative 1 minus g of, be careful here, g of y, that's g of 4, times f prime of x, that's f prime of negative 2. Notice we're going to get these values from the table up here. On the bottom, f of x, f of negative 2, times g prime of y, that's g prime of 4, plus 1. Alright, so let's see what these numbers are. We have negative 1 minus g of 4, that's 5. Wow. Okay. Times f prime of negative 2, that's 4, over f of negative 2, 3, times g prime of 4, it's 2, plus 1. So we have negative 1 minus 20, negative 21 on top, over 6 plus 1, 7. Hopefully this is one of the answers. Oh boy, yeah, negative 3, got it, yay. Okay, well, so negative 3, that's the final answer there. Let's keep it going. Okay, so here we have question number 7. The graph of the decreasing differentiable function f is shown above. Also shown is the line tangent to the graph of f at the point 4, 6. Okay, so that's the point 4, 6. We have f of x, and we have the line that is tangent to it at this point. Let g be the inverse of f. Which of the following statements about g prime is true? Okay, so here we have to remember the property about inverse of functions. We know that if f and g are inverses, that means we have this theorem. We know that g prime of x is equal to 1 over f prime of g of x. Now the tricky part here is finding out what x is it that we want to figure out, basically. Look at these inputs, 4 and 6, basically, right? Let's see if we have 4. g prime of 4 would equal 1 over f prime of g of 4. Okay, do we know what g of 4 is? Let's see, not from the graph because the graph is of f. And, okay, so here we have to remember a property of inverse functions. We know that if f of 4 is 6, then g of 6 is 4, simply because f and g are inverses. Okay, so remember their x's and y's are switched. Okay, so if we look back to this equation, we don't have this guy. We don't have it. So it cannot be A, it cannot be B. Alright, let's keep going. Let's check for g prime of 6. We have g prime of 6 would be 1 over f prime of g of 6. Well, this one's more useful because guess what? We know that g of 6 is 4. So we have 1 over f prime of g of 6 is 4, so f prime of 4. And from the table and the graph, we can see that f prime of 4 is 6. Psych, f prime of 4 is not 6. F prime of 4 means a derivative at 4, right? Or the slope of the tangent line at 4. So we need to find the slope of this line. And we can do that by counting. Let's see if we can pick a good point. From here to here. Okay, so we count the slope. 1, 2, 3. 1, 2, 3, 4. And notice it's a decreasing slope, negative slope. So m, slope of the tangent line, is negative 3 over 4. Okay, and that's the slope at 4 in particular, or specifically. Meaning that we have, going back to our equation down here, we have 1 over f prime of 4, which is 1 over negative 3 over 4, which is negative 4 over 3. And that's letter C. That was a good one. That was tricky. Tricky. So the key thing we have to remember here is that f prime of 4, what does it really mean? And what it means, again, it's the slope of the tangent line at 4. So we had to find the slope of that line shown there. Cool beans. Alright, let's keep going. Here's the next one. The table above gives selected values for a differentiable and decreasing function f and its derivative. If g of x equals f inverse of x for all x, which of the following is the correct expression for g prime of 2? Cool, so another question about inverses. Notice. Alright, and they're telling us that g and f are inverses, and they're asking us for g prime of 2. Okay, so again, the property of inverses, if f and g are inverses, that means g prime of x is 1 over f prime of g of x. Okay, so keeping that in mind, the question here is what is g prime of 2? So we have g prime of 2 would be 1 over f prime of g of 2. Okay, but what is g of 2? We don't know necessarily, but let's look at this point here. So we know that f of 2 is 5. Which means that g of 5 is 2. That doesn't help. Okay, let's look at the next point though. The next point says that if f of 4 is 2, okay, that means that g of 2 is 4. So again, these are properties of inverse of functions. Remember, you switch the x and y's, right? And g of 2 is the point that we needed in order to continue with our equation. So going back to our equation, we have 1 over f prime of g of 2, which is 1 over f prime of 4. and we look back to our table here, our table, let's see, f prime of 4 is negative 5. So we have 1 over negative 5, which is letter C. And there you go. Okay, so these things get a little bit tricky, but this is a key rule to remember. So if f and g are inverses and x comma y are points in f, that means that y comma x would be the points in g. I hope that makes sense, but what I'm saying is that you switch the x and y. Okay, let me see. Let's go to the next question. Okay, boys and girls, here's number 12. Which of the following methods can be used to find the derivative of y equals arc sine of x with respect to x? Use the quotient rule to differentiate 1 over sine of x, use the chain rule, or implicit differentiation. Okay, now if you remember, we spent some time deriving the inverse trig functions, the derivatives of the inverse trig functions, and they had to do with those triangles or using the identities. So we'll review that right now. Let's go through the first option. Use the quotient rule to differentiate 1 over sine x. Okay, so this one definitely cannot be our choice, our answer, because 1 over sine x, that's the same thing as cosecant x. And cosecant x is not at all related to arc sine of x. They're not related. Okay, so that cannot be it. And if you notice, that eliminates some of our answers. It cannot be A, it cannot be D. Right, so now we have a 50-50 chance. It's either B or C. But let's go all the way through. So the second one is use the chain rule to differentiate sine of arc sine of x equals x. Okay, so using chain rule, notice that this is composition of functions, sine of arc sine of x. Chain rule says take the derivative of the outer function, that's our sine of x, derivative is cosine. Keep the inside, here we are, keeping the inside. Multiply times the derivative of the inside, d dx, arc sine of x. Notice that this question is asking how could we derive the derivative of the inverse function? That's what the question is asking, right? So we're about to solve for that once we finish writing our equation. We need to take the derivative of the right side, the derivative of x, which is just 1. Okay, now since once again we're solving for this guy, we'll divide both sides by the cosine, so divided by cosine arc sine x, and on the other side too, cosine of arc sine x. Alright, we're left with the dx of arc sine of x is equal to 1 over cosine of, and let's pull out a trick here, cosine of arc sine of x. If we look back at the original, arc sine of x is just y. So really what we have is 1 over cosine of y, and here's where the triangles come in. Alright, so let's go back to the original equation. They told us y equals arc sine of x. Remember how you undo the arc sine? Is that you sine both sides, right? So sine of y would equal x. And from here, we're going to pull out the triangle. It says sine of y equals x, meaning that y is the angle. Y is the inside of the trig function, so that's our angle. We'll place it here. And x, we can write it as x over 1 to make it look like a fraction. Now remember SOHCAHTOA, sine is opposite over hypotenuse. Okay, so let's fill those sides in. Opposite goes here, hypotenuse is over here. Using Pythagorean, we know that the sum of the legs squared is equal to 1 squared, right? So x squared plus question mark squared equals 1 squared. We want to solve for the question mark, so question mark is equal to square root of 1 minus x squared. And the question mark is down here. Okay, that's our square root of 1 minus x squared. Now remember, we already have an equation. We know that the derivative of arc sine is 1 over cosine y. The thing is that we don't want it in terms of y, right? We want to figure out what is cosine of y, but in terms of x. That's why we needed this little triangle up here. So cosine of y, Remember, that would be cosine means adjacent over hypotenuse. Which is our question mark, square root of 1 minus x squared divided by hypotenuse is just 1. Alright, so going back to our equation down here, we can fill it out now. That means that d dx of arc sine of x is 1 over square root of 1 minus x squared. So yes, we can use the second option. So basically right now we know that it's C because the second option works, but let's be good mathematicians and let's run it through to the end. Alright, so this last thing says use implicit differentiation to differentiate the function y in the relation sine of y equals x with respect to x. Let's see what the heck does that mean. I'm going to leave the little triangle up there because I feel like it's going to be useful again. And here we go. They're asking us to solve this equation using implicit differentiation. Alright, well, sine of y, we would take the derivative of both sides, right? So here we are taking derivatives. The derivative of sine is cosine y, but it's a derivative, so that would be cosine y times dy dx equals, derivative of the right side is just 1. Then here we are again having to divide by the cosine. We get dy dx equals 1 over cosine y. And from here, same deal. You have to refer back to the triangle to figure out what cosine of y is. But we already did the dirty work. So here we go. Just plug and chug. Dy dx equals 1 over the square root of 1 minus x squared. We got the same result as before. And the third option works as well. So chain rule works, implicit differentiation works, and the first one was bogus. There you are. Thanks for hanging in there, guys. So here's the next question. Just a few more. Oh, look at that. Only 2 more. Alright, so here we have a graph, and it says the figure above shows the graph of f prime. Super important that we pay attention to these things, whether they're talking about f prime or f. Makes a huge difference. Alright, so here we have the graph of f prime of x, the derivative of the function f. At which of the 4 indicated values is f double prime of x the greatest? When is the second derivative the greatest? Okay, what can we say about these points? How are they different? Now again, this is a derivative. This is the graph of the derivative, and they're asking us at which of the 4 indicated values of f of x is f double prime of x the greatest. Alright, now remember f double prime, that would be the derivative of this guy, meaning the slopes of the lines on this guy. Alright, so here at this point we see that we have a relative max, right? Meaning that f double prime of c should be 0. We have a tangent line, or sorry, the tangent line is horizontal. We have a horizontal tangent line. Okay, so should not be C. Here, how is this slope behaving? Well, we see that it's positive. Right, so here we can say that f double prime of b is greater than 0. Here, how is this tangent line behaving? What's the slope like? You can see that it's negative, it's decreasing, it's quite steep. We could say that f double prime of d is negative. And here, this guy is also a positive slope, but pretty flat. If you notice, it's almost down here at the peak, almost at the minimum, but not quite there. So we can say that f double prime of a is positive, but we can also say that f double prime of a is less than f double prime of b, which means, boys and girls, that our final answer here would be the greatest positive number. Whoa, what happened there? Uh-oh. Which means that our answer here would be the greatest positive number, which would be b. Okay, so here we go, number 18, this is the last one. It says, let y equals f of x be a twice differentiable function such that f of 1 equals 3. Okay, so we have a point, 1, 3. and dy dx equals 4 times the square root of y squared plus 7x squared. What is the value of d2y dx2 at x equals 1? So twice differentiable, again, that means that we can take the second derivative. We can take the derivative twice, and that's exactly what they're asking us for, the second derivative. Okay, so they gave us the first derivative, dy dx equals 4 times square root of y squared plus 7x squared. That means that our second derivative would be, and here we have to be careful with what we have. Notice 4 is the coefficient, and this is in the form of chain rule, and I'll show you a little bit here. This is the same thing as 4 times u to the 1/2. Okay, so what we're using here is the power rule, and our u is that y squared plus 7x squared that's on the inside. Okay, so power rule says pop the power to the front, so that's times 1/2. In parentheses, keep the inside. Inside stays the same, remember? And subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2 times, don't forget, the derivative of the inside. Okay, so here we go. The derivative of y squared is 2y. Don't forget the dy dx. Plus derivative of 7x squared, that's 14x. Okay, and all of that goes in parentheses there because it's all being multiplied. Okay, now let's see if we can cancel anything here. We can cancel here, this on top, this on the bottom, so this becomes a 2. And let's see what we have. Let's write this as a fraction. Notice a negative exponent down here, so that's going to the denominator. And we have a 2 on top, so 2 times 2y dy dx plus 14x, all divided by y squared plus 7x squared inside the square root. Okay, and this is our second derivative. Now they want an actual value, not an equation, meaning we have to plug in the stuff. So we know that x is 1, that's in a given. We know that y is 3. Notice that we have y's in here, we have x's, but we also have a dy dx, right? So what do we do for dy dx? Well, luckily we have an equation up here. Okay, equations are our friends. Let's plug in the 0.1 comma 3 into this equation. We have dy dx at 1 comma 3 is 4 times y squared, that's 3 squared, that's 9, plus 7 times 1 squared, that's 1. 9 plus 7 gives us 16. Good news, boys and girls, that's 4 times square root of 16, which is 4 times 4, which is 16. Okay, so we have our last value there, dy dx is 16. Okay, now it's just plug and check. It becomes a arithmetic question, but tomato, right? So let's plug in the stuff. 2 times 2, let me use a bracket for neatness. 2 times 2 times 3 times 16 plus 14 times 1, all divided by square root of 3 squared, that's 9, plus 7. Okay, so we know we're going to have that 4 on the bottom again, or the square root of 16. 2 on top, and then it's 6 times 16, we have 96, plus 14. Let me simplify this fraction here, 2 on the bottom. Here we have 100, 110, so we have 110 divided by 2, which is 55. Okay, looks like a good answer because it's on the list. And that's it, boys and girls. Those are just a few questions that I wanted to review with you guys, since I noticed that quite a bit of you got them wrong. I hope this video helped. Let me know if you have questions or anything on here wasn't clear. Okay, stay safe, guys.